looking at terms, detox versus drainage. As far as these terms, there's a big difference between the words. Detox, I think of oftentimes as we're going to grab on to harmful chemicals, pulling them out of the body. Drainage, though, is referring to the normal pathways that the body uses to move these toxins and debris out of the body. So the first thing we want to support is opening drainage pathways. Just think of it almost like the plumbing, right? If the sink is clogged, you don't want to put more stuff in the sink, i.e. detox the body. You want to open the drainage. You want to open the sink up so the body can handle when the body is detoxing. And when we're looking at drainage, the pathways responsible for drainage, the colon, bowel movements, just pooping, that's one of the most critical ones to make sure it's open because it's at the very base. We've got the liver and the bile duct system, the lymphatic system, the brain drainage that happens to the lymphatics, often referred to as the glymphatic system. We have kidneys and just excreting urine, sweating through your skin, right? These are all drainage pathways, but there's a priority to them. So as I mentioned, there's an order of priority. So as you look at this diagram and you look at it, you basically want to start from the bottom up, because if the bottom gets clogged, everything above that funnel is going to get clogged. And you can see at the very bottom is the colon. So we don't want the colon to be backed up. But the more that colon's open, the less likely we're going to back up the next areas above it, which the liver and bile duct system, right? That is dependent on the colon moving. So if the colon's backed up, automatically liver and bile duct system's backed up, lymph is backed up, organs and tissues and cells. And so as we're looking at it, above the liver and the bile duct system, like I mentioned, we have the lymphatics. Above that, so every layer above is dependent on the one below it. And in order for the brain to drain, the lymphatic system has to be draining. So if we say the brain is an organ, tissue, it's dependent upon the lymphatic system. So if the lymph is clogged, the brain can't drain. If the brain can't drain, right, and you could say this is the glymphatic system, the brain drainage. If the brain is not draining, symptoms can occur, potentially like brain fog, headaches, memory issues, not thinking clearly, can all be signs that we have poor brain drainage, which is dependent, again, upon lymph, which is dependent upon liver and bile ducts, which is dependent upon the colon. So now let's look at when the system gets backed up. So let's say the colon's backed up. Then automatically that's going to back up the liver and bile duct system, which is going to back up lymphatic. And you can see it's kind of overflowing in the image, right above. But what happens on that image is this little emergency hatch opens up. The emergency hatch is how the body is trying to get rid of these things. So as we're looking at the drainage funnel right above me, you'll see I added a power switch. So in order for the colon to have electricity, if you will, in this analogy, or to have energy for it to move and have peristalsis and do its function and absorb the water that it needs to in the large intestine, in order for the liver bile ducts to be functioning, it is the mitochondria that powers that whole thing. So in order for the drainage funnel to function, it has to have power. It has to have ATP. It has to have energy. And the power switch is the mitochondria. So we can't forget about the mitochondria. It's important to support this, just like drainage pathways at the beginning, to get mitochondria supported, drainage supported. Just know mitochondria and drainage, we focus on it right away at the beginning, but it's going to come along with you for the journey. And depending on how you progress, you might need to alter or increase, bring up some more support of drainage or mitochondria, because that'll help symptomatology. So just remember, this is a journey. Drainage is not something you're complete and like, I'm done, I'm never coming back to it. No. Now, talked about the roadmap to health. In a reminder, right, we have the 5 different phases, which can be broken up into the first four steps, if you want to call them as well. But the first step or first phase is energy and drainage. Energy is referring to mitochondria, the mitochondrial health. They generate most of the energy within the body. So if you see that image right above me, the chemical formula, adenosine triphosphate, otherwise known as ATP. This is the energy currency of the body. Now, there's 2 different functions of mitochondria. If you think about back to the basic biology class that we probably had in high school talking about ATP and energy and the mitochondria, that's one of the main functions, right? The ATP, so you have your cells, you have a bunch of mitochondria inside the cell. These mitochondria are making ATP, which is used as an energy carrier in metabolism. Think of it as like housekeeping for the cell. Keeps everything running, keeps it all tidy, clean, functioning. Now, as soon as there's a perceived threat, it can be a real threat or actually just a perceived threat, that ATP, instead of staying inside the cell, will actually leave the cell and it'll become a signaling molecule. They call it a mitokine. You can also think of it as a eATP, and the E stands for extracellular, right? So it's leaving the cell. This is when the ATP functions massively with the immune system because it's acting as a signaling molecule, defense and communication, to help with innate immunity, inflammation control, metabolic memory. This is what Robert Navio's work, which I highly recommend this paper, the citation there on the side. Dr. Robert Navio, cell danger response. Super important to understand, very critical, but the key takeaway from this slide is there's two main functions of ATP. Inside the cell, keeping everything functioning, energized, helping metabolism. As soon as there's a threat or a perceived threat, that ATP will leave and send out and be used as communication. Mitochondria also coordinate over 500 different chemical reactions in the cells. So mitochondria is super critical. And I love these graphics here. So we got the mitochondrial impact wheel on the left, and in the middle there, the mitochondrial dysfunction wheel. So what does the impact wheel mean on the left? These are all the things that the mitochondria impact. Drainage, immune system, hormones, regeneration, detoxification, enzyme activation, energy, memory and thoughts, neurologic function. All those things are impacted by mitochondria. So if your mitochondria function optimally, you're going to have positive impact of all those things. If they're dysfunctional, you're going to have negative impact of all those things. And this mitochondrial dysfunction wheel is giving you what are all the things that can damage and cause the mitochondria to be dysfunctional. Mitochondria are the main thing. The disease process happens because of mitochondrial dysfunction. So the question that I believe is so important to ask, what are the upstream sources damaging the mitochondria? And that's what we want to figure out and we want to remove. Because if we remove the sources that are damaging the mitochondria function can increase and health is going to increase.